An Introduction to Set Theory and to Philosophy and Methodology of Mathematics and Computer Programming by Jan Plaza. Russell's Paradox, an overview. At the end of the 19th century, the German mathematician Georg Cantor introduced non-axiomatic set theory. A little later, the German philosopher Gottlob Frege tried to develop a formal system involving logic and sets. Frege's system involved so-called comprehension schema. I will disclose right away that this is going to be very problematic, and eventually it will be retracted. The comprehension schema said that for any property P, there exists a set of elements that have this property. The property is assumed to be expressed by a formula, let's say at this point that a first order formula. So for any property P of Z, there is a set which we will write as the set of those Z that P of Z. Please notice that there is an essential difference comparing to the separation schema. The separation schema was allowing us to form the set of Z from some known set X which have the property P. However, Frege thought that a more general version is possible, and that version of the schema is known as the comprehension schema. About 1900, the Italian mathematician Ernst Zermelo and also the British philosopher Bertrand Russell noticed that comprehension schema leads to a contradiction. This is now known as Russell's paradox. Their reasoning was as follows. Let's consider P of Z to be Z is not a member of Z. Well, with this formula, we should be able to form the set, let's call it Y, of those elements Z that Z is not a member of Z. Now, let's ask the question whether Y is a member of itself. Well, Y is a member of Y precisely when it satisfies this condition, which means if Y is not a member of itself. And this, of course, is just a plain negation of Y being a member of Y. So we have something of the form P equivalent to not P, which is a contradiction. A statement P cannot be given any truth value which would make this kind of equivalence true. So the comprehension schema leads to a contradiction. And for this reason, comprehension schema cannot be used in a set theory based on classical logic. To explain this paradox better, Russell formulated another version of the paradox known as the Barber paradox. Here it is. In a kingdom, admittedly a small one with just a handful of men, the king ordered the barber to shave exactly those men who do not shave themselves. The barber is a man. Is the order possible to fulfill? Well, if the order is fulfilled, the barber shaves himself. The barber shaves himself if and only if he doesn't shave himself. Contradiction. Another paradox based on this idea is known since the times of ancient Greece from the Greek philosopher Epimenides in the 6th century before Common Era, and also from they formulated so-called liar's sentence. This sentence is false. Is the sentence true or false? If it is true, then it is false. If it is false, then it is true. A contradiction. The idea behind the Russell's paradox, Barber's paradox, liar's paradox has other important uses in mathematics. It is a base of so-called diagonal method, which we will encounter later. At this point, let me mention that we're going to use a certain convention. If the set X is known from the context, we will write this instead of although the notation we're going to use looks very much as the one resulting from the comprehension schema, let's notice that X is expected to be known from the context. So this really has nothing to do with the comprehension schema. We are still using separation schema, and thus we are avoiding the paradox. We're avoiding Russell's paradox.